on this computer. All right. Oh, we'll be recording. That is a great question. It is something that normally we would not be draconian about, to be really mean about, because most stuff you're going to see online, hey, it has C out and C in. Oh, big whoop you do. C out and C in are C++. They are not C. So if you're trying to do a procedural language like C, and let me just switch off this. If you're trying to do a procedural language like C, C out and C in do not exist. You can't call them. They don't exist. Like, so if you went to and put it onto an onboard chip, or if you're doing something in pure C because you're doing something with a network, you can't call C out and C in. As a result, but on top of that, we're trying to make a distinct difference between C code and C++ code, because in 2400 we do C++ code. Sure, like we do a little bit of a review of 1400 and then we go right into C++. And then we see why C out and C in look the way that they do. If we try and do C out and C in 1400, it gets sort of a mixed bag of different things. And on top of that, how do I frame this nicely? If we allow C out and C in, a lot of C out and C in, if you go online, a lot of programmers don't know the difference. And if you go to an external website to use, to ask for help for your exam, which somebody actually did, then they'll give you all sorts of C out and C in statements. And if you don't know what you're doing, you will suddenly have your final exam with wrong answers. If we don't allow C out and C in, and somebody else writes the code for you, they don't know that particular policy. And yeah, we catch people that are trying to break that particular policy. It's a good habit to get into, to try both ways, much like learning a language. Like, there's no right language. I know that some people may disagree with me on that one, but there's no like, oh, French is better than English or English is better than French. They're different. They have different strengths and weaknesses in each of them. I personally think swear words sound better in, well, they sound good in Quebecois French, but don't sound good in France French. I don't like swear words in France French. So like that, it's good to get in the habit of trying both. In this case, C out and C in is you try printf and scanf, make sure you understand, and then you can try C out and C in. Now you know both ways, and you can choose which way you want to do it later. Okay, so that is very true. That I will say. I'm not going to actually say the word out loud though. Is that the spelling of it for the T word? Anyways, but yeah, France French, I don't find it very satisfying to swear in, but great in Quebecois French. There's a nice guttural sound. Okay. Yeah, unfortunately, a lot of people would have done C out and C in high school. I'm surprised you did C++ in high school. Thanks, Paul. That's the thing you're going to take away from this lesson, is how to spell swear words in French and Quebecois French. So I wanted to see what people wanted to go over. Do you guys need any help with how to start up a project, how to write code, where things are going to go horribly off the rails for you when it comes to code, the scaffolding of the code, that sort of thing, right? A couple printf statements. That's what my original plan was. Do you want to just go over the exam, right? More than happy to. So whatever you guys want. Oh, a night. Great. Assignment 3 was fun. Assignment 4 is going to be very similar to assignment 3, but with functions. So lectures, can we use the statements for? Oh, exercise at the end of 7E. What is 7E? Can you clarify that, Luke? Sorry, I'm all my lectures were done a while ago. So your next exam, I do believe it's November. It is in the course outline. So Daniel, so that would be a good thing to look up. It's the plan of attack was I learned the hard way last 2 terms that Carleton, when you make an exam, you have to have that exam on that date, the day you said, unless there's something horribly, horribly wrong. Oh, there you go. I'll work on that. And if you don't do that, so what ended up happening was I had my exams at the perfect time for my class, but I couldn't take into account the other classes you guys have. And so I moved it back further and before so that you don't have all of your exams all at the same time, because that's not fair to you guys at all. So that's why it's November 25th. Okay, is even. That takes a single integer and returns 0 if false and 1 if true. You could do it without an if statement technically. Now, if you want to use an if statement, great. If you don't want to use an if statement, that's fine too. The reason you can use an if statement, or you don't have to use an if statement, is because technically true and false is either it's 0, which is false, or not 0, which sounds weird, but that is a C and C++ thing. I think even Java follows that. A lot of languages do that. If you need something true or false, and you have, like, say, a character, well, it's either 0 or not 0. That's how everything is built essentially with a computer. So, and so, yeah, we don't have class next Monday for Thanksgiving. Yeah, so hopefully I won't be working on Thanksgiving, but I probably will. So let's go over is even, see if we can plug through that one and see how we're doing with that. And let me also start up a brand new project while we're at it, because I had some questions over the weekend, like where curly braces were not there, or we didn't have a main method. Another portion of lab 3, are we not allowed to use an if statement? Oh, that's pseudocode though. For the GCD, it's a pseudocode question. So there is, you can say all you want if there's an if, some kind of conditional, and do it that way. I'm not asking for the actual code because you're not ready for that yet, or I cannot assume people are ready for that. But the GCD as pseudocode, go for it. Knock yourself out. Use if statements, use loops. If functions return a Boolean value or 0 not 0 thing, and we'll do that in a second. And pseudocode, if I remember, we could. Yes, perfect. So let's make a project, a brand new project. I'll work through it. Post other questions when you have them, and we'll see how we go from there. I'm going to just share my screen, hopefully. Share my screen. I'm going to share the whole screen. About the screen. I got to go back in here. Share it. All right. So here is my Visual Studio that I'm going to be working with. I'm going to make a brand new, create a new project. And I'm going to make an empty project because these Hello World projects, these console apps, will make a Hello World default, and they're going to put all sorts of crap in your project. There's going to be all sorts of pre-generated code, which means we can't test your code as easily, and you can't test your code as easily. Microsoft just, it's inserting all these predefined variables and the like. So we're going to make an empty project. And I'm going to, but let's see if I can put this in another repo. Hopefully it's not going to be some incriminating folder like your exam marks or something. Let's see here. 1400. Do we have in-class code? Class code. All right. So let's make it, put it in this folder. Select that folder. And I'm going to call it sync test 1, hopefully. Sync test is even. How about that? Even better. And I'll put an underscore in there. I'm making a brand new project, and people give me all sorts of weird things with their projects. And if you try and make something other than a C++ console, that's the basic, that's a vanilla form, it's going to be problematic for you. Okay, so I'm going to create this. We should get pretty much absolutely nothing as a result. Boop-a-doo. All right, now my entire screen got covered over. So that's not so much fun. Sync is even. Oh, damn it. Okay, there we go. Thank you, Zoom, for blocking everything. Okay, so I'm going to make a brand new item, and it's going to be a C++ file, and I'm going to call it, instead of source, that's a crappy name, I'm going to call it is even test. Let's call it that. Okay. And all it's going to do is make a blank file. Now, before we get going, you only get one main method. This is the go position in Monopoly. This is the starting position in Snakes and Ladders. This is every single game, every single thing has to start somewhere. The default for starting somewhere is main. It actually is the start and end of everything. So here's mint main. I'm not going to put any parameters in this thing. When I'm done, I'm going to return 0. I'm going to return something. I could have void there. That's fine. It means I'm not going to return anything at all. The reason you might want an integer, there's 3 different versions of main that you can do. There you go. 3 different versions of main you can do. One of them takes an int. The reason it takes an int is because people went, well, it's a function, it should return something. And if you have an error or something along those lines, maybe you might want to return something so that other programs can use it. Fine. So int, and I just return 0 at the end. I can do void up here. That doesn't return anything at all. It just stops. Same difference essentially. And the third way that we're going to be dealing with our main, at least in this course, is we're going to have something that can take parameters. You can type in your program, pass information into your program through a series of things in these parentheses here. We're not doing that yet, but later on we'll be doing that. So passing in parameters into your program to get it going. Like those little flags when sometimes you have to write, if anyone knows like tar or any of these other things, when you're typing things on a command line and you have to put like -e and then some other thing, right? That's input parameters. Okay. That should do it. Okay, let's do a printf. Let's just do a hello world /n, right? This is put it on a new line afterwards. And I need to figure out what the heck I'm missing here. Oh, wait, I need to include some stuff in here. So I'm going to include IO stream, let's say. I could have included a bunch of different things. A lot of these things should actually do printf, but IO stream would be one of them. I think standard library will give you printf. There's a lot of things. If I leave it off though, okay, let's save it again. And look, I get an error. I know it's an error because it gets underlined. And I can go to my error here and see what the options are. Include standard IO, that's probably the base one. Okay, let's include that one instead of the IO stream. So these error messages, you can just go to the side and see how to fix your own error messages, which is quite nice. Let's see if we have another chat question. Do you know when to use int or void? I always use int. That's a great question, Maurice. I always use int just out of force of habit, but I don't think it's one way or the other. Do this week. And yes, you always have an assignment to do this week. I'm posting it, but I post it after the last one is put up. I put it up immediately afterwards so that you don't go, which assignment do I pass in? Yeah, if you're not returning anything at all, you can return void, but a lot of these things, you return an integer and it's just 0, just out of sort of philosophical reason. We call them functions. Functions return something. Methods don't. But from a mathematical standpoint, the idea of a mathematical function, it always returns something. Okay, so that's my hello world. Great. I'm going to see, let's chat one more. I'll avoid the chat for 1 second. Sorry. Now, we're going to get ahead of ourselves here. And I'm going to say int is even, and this is going to take in to check. All right. This is me making a function. This is what's covered this week in class. So it's good to look it over anyways. This is what the question was earlier. If I have something, a function like is even, do I need an if statement? Actually, technically you don't, but we can put in an if statement. And so it looks just like my main because that's a function. And the only way I ever call this function is if my main method calls this function. So what will end up happening, and I'll walk through our program, and I'll say int I'm going to call the function up there. I'm going to pass in a value like this. Let's pass in a couple other values. 2, and I'll pass in an, let's say a 0, and we'll pass in one more. 6. Okay, so these are 3 different calls to the same function. So what's going to happen is I'm going to go line by line. When I get to this line, I'm going to jump up here, do all of this stuff up here, and then jump back down. Do the next line, jump up, do all this stuff here, put a value into is even test, whatever this thing spits out. Jump back down, jump up, go up, do a bunch of calculations, jump back down. So I'm going to put a breakpoint in here. So this is me clicking on the gray box on the side of this thing saying, hey, this is where I want my code to stop. So I can walk line by line through my code. If you don't practice this thing, people will avoid practicing it. I know I did. And then you'll spend far too long trying to come up with, how to do things. Okay, I'm also going to do some printf statements. So printf is even test 1 is okay, and I'm going to put a new line in this thing. All right. Copy and paste is your friend. Okay. Not always, actually. It gets me in trouble, but it makes you look like a badass programmer for a little while until you get introduced to all these bugs. Okay. So this is me calling the same function 3 times. I'm going to do some kind of printf statement 3 times just to spit out what the values are. I still haven't even done this function yet, by the way. I'm testing what kind of code I can write, what kind of tests I would want to run on this thing. What do I want to check? I want to check an odd number. I want to check an even number. Maybe I want to check, let's do another one. -6, right? Try a negative value, right? And I can, let's put, I'll leave it at that. Okay. Let's just return, we're going to fix this, but let's just return this at the end just to make sure my code compiles. And if it doesn't compile, I need to figure it out. So I do this in 2 steps. Do not do it as 1 step, despite the fact half of you will still do it in 1 step, right? Everyone goes compile and they'll just press the play button up here. It'll compile and then they'll run their code. And then it'll say, oh, you have a bug in your code. Do you want to keep on going? And people will collect the don't ask me again button, the little checkbox, and say yes. And they will be looking at wrong code for an entire assignment. Compile, make sure it works. You can't go anywhere else until it compiles. Compiles makes it into machine code that people can use, that the program can use, or the computer can use. So I compile 1 step, and then afterwards, then I can test it, or I can run the executable. This is the machine code. If I don't keep those separate and I try and do it all in one go, I will not realize that I have a bug in my code. I have an error, syntax error in my code, so it doesn't compile. And I'm looking at an old version of what my code was. And you can spend days looking at that damn thing, honest to God. Okay, I want to just see the chat first, and then we'll get on to the other stuff. For this week, yeah, and the clock is for the tutorial. Great. You will not lose points for using void instead of int main. That's more philosophical. Yeah. You would lose points for using cout and cin just because we need to force you into the habit of using printf and scanf. Normally I wouldn't, but because of the nature of this whole pandemic, learning from remotely, the temptation to cheat might be too strong for a lot of people. So we're being a little bit more paranoid. Okay. Scanf_s is correct, not just okay, but correct. The _s is for safe or secure. The old version, I say scanf because I grew up with scanf and then they suddenly changed the function on me. But yes, Daniel, perfect, great question. All right. So let's actually think through our code here. I need to check to see if this number, let's say the number 7. So when I call this function here, I will jump up here. This toCheck value here will be the value will be equal to 7. I can look at this with my breakpoint. It's equal to the number 7. And then what I want to see is it an even number? Okay, so how could I check to see if something's an even number? Well, what if I divide that number by 2? That is technically how you could define an even number. Is it evenly divisible by 2? Or in other words, does it leave a remainder? So this is the mathematical way of doing things. So what I could do is say toCheck mod 2, right? I'm checking to see if So if it's an odd number, the remainder will be 1. If it's an even number, the remainder will be 0. This is the exact opposite of what I want, but I can work around that. So I either get, there are a number of different things I could do here. This is the easy one. That means not a remainder when dividing by 2. So if I have 7 remainder 2, I get 1, not that. So if it was a 1, it now becomes a 0. If it's a 0, it becomes a 1. That's what not does from a logical standpoint. You could have also said plus 1. Well, plus 1, no. Let me think here. If I subtract 1, what will happen? It'll go to 0 or negative 1. That would also work. So other approach might be, because it's either 0 or not 0. No if statement whatsoever. I'm just using math. That's it. I'm not expecting many of you to necessarily go, oh, that's obviously the answer. But especially if you know if statements, if statement will also work just fine in here. So we'll look at an if statement in a second. But this should do it. So I check to see if it's divisible by 2. If it is divisible by 2, I say it's not. I say not that. If it is not divisible by 2, I say not that. So if it was, I can break that down even further if you want to as well. So let's do int remainder is equal to, I'll put this in here. Break it into 2 different chunks so we can look at the code. Not remainder. And that should do it for us. All right. So let's compile this sucker again and see what happens. And we're actually going to walk into our program this time. All right. So I should stop right on this line. I've done my hello world. I'm going to go into is even. I'm going to take a step into that function. I'm going to step into F11, this particular function. Notice I jump up here. What's to check? It's equal to the value 7, what the parameter was. This variable is created brand new, and it gets assigned the value 7, the thing that called it. I'm going to walk down this thing. So F10, in case you didn't know if there's a hotkey for it. The remainder is equal to, so 7, remainder 2 gives me a 1. If I say not 1, it should be equal to 0. I'm going to take one more step. I'm going to, when I say return, I stop what I'm doing. That function is done. I put 5 other lines afterwards. I'm not doing those 5 lines. As soon as I see the word return, I'm done at that point. All right, I'm going down one step. Let's check what is even test gives me. Hey, it gives me 0. It's not even, it's odd. So therefore 7, this is even for 7, gives me 0 or false. We don't have a word false in C. It's such an old language that they actually were worried about the number of bits you had. Seriously, like integers have changed in size over the years because it used to be so, it's such an early language. Okay, let's do this one, 0. So I'm going to walk into this function. I'm going to use that step into thing. I'm going to go one step down. I should do this one instead. One step down, one more step down. I'm going to step over. And this is remainder of 0, and not 0 should be equal to 1. And okay, let's see what is even test. Hey, it gives me 1. That's perfect, right? Is 0 even? Yes, it is. True. How about this one? I can do a step over instead of going into my function. Get away, Zoom. Zoom is blocking me, by the way. It's not hiding. There we go. Okay, I'm going to go one, just instead of going into the function, I'm just going to step over the function and see what. That is me pushing the step over part. Is even test 3 gives me a 1. What the heck? Why is even test 4 equal to some crazy number? Let's have a look. This is, I'm going to look at from a hexadecimal standpoint, just in case. Oh, wait. That's why we have to learn binary and hex. Because if you didn't initialize this variable and try to use it, this is the number that's being stored for that variable. It is just a really big number because it's just a bunch of C's. It's a default sort of setting. It could be anything though, if you didn't initialize it. And so what we want is when things go, like if I don't initialize things, I need to be able to figure out what went wrong. And in debug mode, it initializes all my variables to this thing unless I give it a value. C, 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 C. And if you don't know this or know what hexadecimal is, you get this thing and you wonder what the hell just happened. That's why we have to look at hex. That's why we have to look at binary, because it actually means that you can't debug your code otherwise. Okay, so I'm going to step into this function again. So is test4 for -6. I'm going to check to see what my remainder is. Remainder of a negative number, what should happen? It actually still works. So -6 with remainder 2 should still give me 0. Not 0 should still give me 1. And I pop out is even test4 gives me 1, and then I can print off all of these statements one after the other, and I can look and I can just press anytime zoom for you to go away. Please stop. There you go. All right, and I can just press continue if I want to see what's going on here, and I'm gonna have to move this thing over again. Sorry, folks. And I'm going to look over here and hey, all right, 0, 1, 1, 1. That's actually what I would expect. 7 is odd. The other ones are even. Great. So let me check to see if you guys have other questions. I'm going to do the if version of this in a second. So let's see how people are thinking about this. Topic 3, question. Okay. Topic 3, quiz 2. Is there a quiz 1? Yeah, let's do the if version. Look, it is a lot more intuitive, but we haven't done the if statement yet. So this is one way you could do it just purely with math. There's multiple ways of doing almost any problem. So the quizzes, because of the goat rodeo that was the quizzes and using poll everywhere, leaving them open, and they don't stay open. I'm still trying to migrate stuff over, and I'm putting out flyers along the way. So if a quiz is not there, and it should be there, make sure I'm being fair, first of all. And I need to make, if it's not there when the time you're watching the videos and you're supposed to have the available, yell away, tell me. I'm more than happy to make sure I put it up there, because sometimes I'm juggling a lot of balls at any given time, and you guys got to make sure that you're looked after, right? So if I screw up, I should know so I can fix it. And that's the easiest way to fix it. But yeah, no, you're not supposed to be using poll everywhere. It was such a goat rodeo that I got rid of it and went with quizzes on CU Learn instead. Thanks, Corey. Let's do the if version of that. All right, so we can do an if version of this. So let's do one more version of this. And I'm going to block comment all my code because I can, and I like doing that. Okay, block comment. All right. So what could I do? What I could do is check, see if, I still need to see if it's even or odd. So if to check mod 2 is equal to 0, return, and I could say, technically I can say true, but true, we can look at the numbers in a second. You'll see something weird. Here's an else statement, return false. All right. Let's compile it. Let's see what happens. Notice this thing is saying it's returning an integer, and it's okay with true being an integer. What? Okay, let's run it. All right, let's dive into my program. I'm gonna step into my program. I'm going to take 2 steps in, 1. So the thing I'm checking is 7. So if 7 divided by 2 gives me no remainder, then I'm going to go into that condition. Otherwise, I'm going to go into my else. Hey, I went into my else. Yay. I'm going to return false. What is false? Well, let's find out. Go down one step. Okay, is even test. The value for is even test is, 0. False. Told you. Under the hood, false is equal to 0. True is anything but 0. But most of the time it ends up being 1. But it's anything but 0. All right, I'm going to step into this function. I have a 6, I do believe. No, it's a 0 to begin with. 0. So I'm checking to see if 0 is divisible by 2. If it gives me no remainder, I'm going to return true. Hey, I'm returning true. That's good to know. I bail out of this thing. I'm going out one level again. So I'm coming back from the function. I check to see what gets stored and is even test 2. And that's the value 1. True. It's all, I have to have some kind of criteria. And the only criteria I have for true and false is I can't have like 2 being, I don't know. I can't have -1 being sort of true, maybe, right? It's either 0 or not 0. And so this is what we're returning. True ends up being equivalent to the number 1, but it could be any non-zero value. Okay, and let's check the next one and the next one, and let's print off these things. And let's just continue my program and see what happens. And what I get is exactly what I had before. No difference between the two, just using an if-else statement instead. That's it. So one required an if-else statement. The other one required just some math. No, just some math, but math. And both give you the exact same result. All right. Is that making some sense? So can I break down? Notice, by the way, I cannot, because I had this question on the weekend. Notice this function here is defined starting, it's between here, this opening curly brace, and here, this closing curly brace. That's my main. I cannot put anything outside of this thing. This is where it's defined, right? This is the box where the function is defined. Here's another box where where a function is defined. It opens at the curly brace, closes at the curly brace. That's where all of that code is defined. There's just chunks. Almost every single line, almost, has a semicolon at the end. That's the classic blunder for most students. The reason I say it's a bit of a classic blunder is that this thing is actually how C and C++ and Java and JavaScript and probably about 1,000 other languages tells you when you get to the end of a line, because otherwise that would make a difference. It doesn't. It's completely ignored. Any white space you put in there is completely ignored. Whether I put 2 things on the same line, however I laid things out, this is saying this is the end of an argument. This is an instruction. The end of my line is dictated by this semicolon to say, look, I'm saying it's the end of this instruction. In a language like Python, you don't have that. But if you add a blank white space, it changes your program. And I like being able to go like, let's put a comment in here. This is a comment. Notice nothing changes about the code, right? And I can put spaces around here and maybe another here, or due to this. All right. Because I'm using this semicolon at the end of the line, it tells me where the line, like at the end of my line, right? It tells me where the end of the instruction is. That's why it's there. It's not on every line. If statements don't have it, the curly braces don't have it. But every single line instruction that I'm doing, like calling this function, semicolon at the end, calling another function, semicolon at the end, calling printf, semicolon at the end. It might sound like I'm beating a dead horse, but it is the most common mistake for new programmers, bar none. Heck, it's probably the most common mistake for new programmers going off into industry after graduating with a computer science degree or an IT degree, bar none. It is just ridiculously common. So if you have problems with your code somewhere, first thing to look, am I missing a semicolon? Don't just randomly put them in there, but am I missing a semicolon? Am I missing the opening or closing curly braces? Do they match up? back in the bad old days, let's see, there we go. Back in the bad old days, you wouldn't necessarily know where the end of this curly brace is. Now they actually dash them down, put dashes between them and line them up. But before that, you would have to like manually count like a chump going across the screen. It was bad. It also wasn't color coded. Notice my strings are in red. My special characters are in this purple. My integers, my variable types are in this color. This is make a brand new bucket to store an integer and label that bucket is even test. Put whatever this thing is, the value that this returns, into the bucket that is even test. Write down the value and give it a label, essentially. That's what these variables are doing. So hopefully that's making some sense. I also like Gong Show. Both of them do not involve profanity, which is why I use those terms, because there's a lot of dumpster fire also works. There's a lot of more colorful ways of describing these situations that I like saying, but I'm not going to say it to you guys or my kids. So can I unpack? Nice, a new kettle of fish. That's after my own heart there. Can I unpack anything? Or a whole different kettle of fish. If the system cannot find the file specified, compiler start error. Can you give me an example, Ben? Hopefully. It does happen frequently. So I just would like a more precise example. So you press the debug button and it says there's a compile error. Okay. Then you have something underlined in here. So for example, let's just do this. Boom, we're going to have an error. Okay, we don't see it yet, but notice over here on the far right-hand side, there's a nice red blob saying, hey, there's an error here. And if I go down here, I get this underlined thing. Most of the time, if you have some kind of syntax error, there's a red underline somewhere. Sometimes not. Scanf will screw up for you quite nicely without giving you a red underline. But most of your code, if you try and run it, and there's a red underline, you can't go any further until that's fixed up. And you don't want to guess at what the solution is, much like you don't guess how to do a math problem, right? You have to methodically take, or you're not supposed to at least, you methodically break down the problem and see like, why the heck is this not giving me some kind of fix? 9 times out of 10, the line above it is missing a semicolon, honest to God. But in this case, I can look at, what's causing this problem? Oh, I have a little drop down here and it says add standard IO. Okay. That's standard IO for standard input and output. And I can include that thing, which is what I had included before. Let's see if I can break something nicely. Okay, there we go. There we go. That should break it. All right, great. Something's wrong with something over here, right? Oh, this one actually tells me what the problem is. And I can add a semicolon to the previous line. Darn it. I'm trying to get a good example where things break and you can't easily debug it. Let's see if I can break it this way. That should break things. All right. Damn it, still fixing and finding the problem. Unfortunately, the information's there. It's just really hard to parse it. I really fully appreciate the fact that when you get an error and it's in this monstrous thing in here, right? How do you find it? The answer is you look at sort of the last line or the first, oftentimes I'll look at the very first error that I get and look there. So let's get rid of a couple of these and see what kind of errors I have and compile it. And I will go from the very first line, this one, and work my way down. And once I fix this one, okay, compile it again. Oh, I got another error. Okay, go to this one. Okay, it's thinks it's expecting this. Okay, put it in the semicolon. Compile it again. Okay, it worked. It's very, very methodical. It's almost Zen-like of just chipping away at these things. But this is why in case you didn't know, and in case I didn't beat this to death enough, this is why you don't write all your code and then test it. You write a little bit, test it, a little bit, test it. Notice we didn't even write is even test at first. We made sure it compiled before we wrote the inside of that function. I just had to return 0 just to be on the safe side. But the compiler gives no feedback text. Okay. The code builds, but the compiler gives no feedback text. So it builds, you have a compiler, it compiles properly. And then when you run it, it's then, oh, and the compiler start an error on the start, right? I have a sneaky feeling it's something like this. Scanf, and then we have this, it's not like that. And I need underscore S. And what does scanf underscore S give me? I always forget the syntax. All right, it's going to take in a constant format. So it's going to be something like I, and then, oh, I don't know what this is going to do. It should be something like this, but give me a number. By no means trivial. Okay. Let's now, so let's see if this actually is going to work correctly first. Yeah, it could be that. This should actually blow up quite nicely. I completely meant for it to blow up nicely, that I didn't just screw up a little bit, right? It happens. This thing is telling me an error though. Look, a non-pointer in parameter 2. It's actually telling me, it's giving me a warning. It's allowing me to do it. It's compiling. There's no error here, succeeded, but it's giving me a warning. That's what the green line is. Those are not normally for you to ignore. They are, you can do it, but you kind of don't do it, right? You know, you can walk over that rope and go, you can run across the wet hallway. Maybe you shouldn't. There's a slippery when wet sign here. Maybe you shouldn't do that, right? This is the same kind of thing. So let's actually run it and see what happens. Hopefully it'll blow up. Boom. Oh, darn it. It's going to blow up now, hopefully. Oh, darn it. 43 or 42. There we go. Something bad happened, something over there. Okay, something bad happened. Why? Because I need to have, it needs to be a pointer. That is just a memorization thing for right now. When we get to pointers, we'll see why we need this. But you need to magically have this thing here. Magic, yes, exactly. Why did I put my function above me? Because it's a bad habit. I'll get to that in a second, Corey. That is a fantastic question to go over. So let's also do, so I broke it one way. Let's break it a different way. And then we'll do Corey's question. Because if I forget the parameter directions on this thing, I want to find my bug early. So I write a little bit of code. It crashes. I fix it rather than having, 4,000 lines of code and then finding out which one breaks. You'll spend far longer figuring that one. It still compiles, by the way, just fine. 42, boom, still explodes. Because it's expecting the thing where I'm going to stick the number as the second parameter. It merrily lets me put this down. It's wrong. And you go, oh well, that's going to be this. Still going to blow up, by the way. It's not going to be happy. Oh no, it's not going to even let me do that. Yes, I'm going to stop debugging. You can't take a pointer. Expression must be a valid pointer designation. Okay. You can't put a point. I knew it was crap code, but I didn't know it was going to give me a compiler error. 1. There you go. Okay. Where are you declaring variables? Global variables? Absolutely no. Absolutely no. And LF. So percentage F is a float, and percentage LF should be a long float. If memory serves me correctly, it's one of those things you've got to look it up. Oh, and we can get rid of this parameter because it's not a string, it's just an integer. I need it for a string if I have a string, a whole bunch of characters, one after the other. So this thing will tell me all sorts of stuff. You just got to, unfortunately, have to learn how to understand. It's like, you know, not horse whisperer, but yeah, it's sort of think about it for a long time. Okay. I don't want, you really shouldn't want to put global variables in there. I do not want things like, here's a global variable in case if people want to see what the heck this thing looks like, is even test. Okay. And I'm going to get rid of this. And I'm going to break this for people. Hopefully, remind me to remove. Okay. And then up here, I'm going to do, what am I going to do here? If it's even, I'm going to put that variable up, really up to the top. So I have a global variable way up here. I'm going to is even test is equal to 5. Scanf double variables, but it gives a very odd output when used as an intake. Really, percentage %f gives a so long float because a float is half the length of a double. So I assumed that percentage %f also handled doubles, but I guess not. So if you're trying to pass in a double, it's twice the precision and it could throw everything off. If you're not, that's why you test it and go, oh, I guess I need a long float. This is one of those things that I know it sounds like a cop out, it really does. But there's a lot of things you're going to just either forget along the way or whatever the case is. Like, how do I output an hexadecimal value? Or how do I output something as octal? I don't do that very often. You're going to forget something. And so it's good to just practice a little bit at a time, a little bit of code at a time. -4 quadrillion. Yes, that's pretty much it. The other difference with doubles is you don't want to ever check to see if it's exactly equal to 0 or exactly equal to 1. The arithmetic problems you get, there's a lack of precision at a certain point in time when you have like a repeat number, like 0.333333. A third cannot be represented as a decimal. In binary, 0.1 can't be represented as a decimal properly. So you get this rounding precision error issue that you get. And so you want to check to see if it's below a certain point, above a certain point, but you don't want to see if it's exactly 0 or exactly 0.1 because the number won't exactly be there. It'll be around that range. Okay, so just for future reference. Okay, let's break this. So here is even test. And let's also do one other thing. I said it was a bad habit. I'm going to move it down here. We're going to have an error up here right now. We should at least. Let's compile it. It should error, cause a bunch of errors. All right. Is even test or is even is not defined. Why? Because is even is actually defined all the way down here below main. It's going top to bottom, one line at a time when it compiles. It doesn't know what you're trying to do. So if I need to make sure if I want to make darn sure that it knows is even's there, I need like a table of contents. I need by the way, this thing is going to come later. This is like foreshadowing or whatever metaphor you want to use. I got this. There will be a function called is even. I just haven't made it yet. I owe you one function called is even. Here's my IOU. Int is even, and it's going to take an int. And what's the value to check? Semicolon. This is a prototype. It is just useful for if main needs to know about this function called is even, it goes up here, says, oh, you have a function called is even. Great. Where is that defined? Oh, it was defined way the hell down here, and it goes down and looks for it and finds it. If I don't have this line up here, it doesn't know. It says is even. What are you smoking? Right? I have no idea what this thing is. And so one of the workarounds is if I have to worry about the order in which I define functions, one of the workarounds I could do is just give me a little prototype of all the functions I'm going to use at the very, very top, saying, by the way, these are the functions I'm going to have. And then I can define them in any order I want because it can find it. If I don't do it that way, I need to make sure that the functions are defined in the correct order. That's why I said it's a bad habit, because I got in the habit of putting functions in the right order, not having some kind of table of contents at the top, just to help me out. All right. We talked about is even, and I even changed is even to break something. In the middle of my function here, I'm going to use my global variable and change it to 5. Why? Because I can. Okay. Let's compile this thing and see what happens. All right, I'm going to put my breakpoint back down. I'm going to run it. All right. The first time through, is even should be equal to false. Great. Now, I'm not touching is even anymore in this function whatsoever. Is even is being used by this thing right here, and I'm not touching it anymore. Next step, I'm going to step over, and is even is now, let's see, is even test. Huh, didn't break on me? Let me check on this one. Unless I made a new variable called is even. All right, and take a step through, Oh, I reversed it. Okay, hold on. I'll break everything for everybody in a second. Let's break it this way. There we go. I had it reversed. All right. Every time, all the other times, I'm going to make it break on me here. Okay. Is even test is equal to 0. Next time I call the function again, I shouldn't be changing is even test. That's the variable I'm using. Some other function has access to it. Is even test is now equal to 5. Some other function is changing my value. I didn't have any say in the matter because they're all sharing the same global variable. And if you think this is a little toy example, just wait till you have thousands of lines of code and see people can do that to your code. Global variables, they get you like 3 months from now. Not now, they'll get you later, and you will have a hell of a time tracking it down. So global variables, big no-no. They make a mess. Yeah, that's exactly it. There you go. All of that to just say, don't use global variables, bad, bad, bad. Global constants, completely different story. Why? And that's one of the questions. It's a rhetorical question on the assignment. But why are global constants okay? If anyone wants to write in the chat, that would be great. So something like constant int my pi, whatever the pi is, because they don't change. That's exactly right. You can't go around, some other program can't go around messing with it. If you can't change it, I set it to this. Other people can access it. Maybe they need access to it. No one can change the value on me. And so I don't have these weird side effects. Because I'm not sure if pi is actually defined some other way. I do it all capitals, so that's by convention. So this is saying, by the way, just in case you, like, I want to be able to, I have a horrible memory. A lot of programmers do. What I don't want to have to do is figure out if that's a constant or variable or this or that. If it's all caps, I know it's a constant. If it's spelled like this, I know it's a variable. Right? I can tell based off of how the formatting of the text is. I go upper and lowercase so I can read it as 3 different words. Is even test. Upper and lowercase. It's called camel case because it goes up like camel's humps. But my pi, all caps, is our convention for this is a constant. It ain't changing. So when you see something in all caps, you go, okay, it's a constant. I cannot modify it. So it's a nicety to have. And it's called my pi just because I could call it, I think I might be able to call it pi. I wasn't sure if the math library, for example, has a definition of pi already. So if I include math, if I can type, okay, let's see if the math library has this. So pi, do I have a math pi? No, I'm not seeing pi anywhere. It might be fine. Or it's not or it's something else I haven't hit yet. Because pi it's one of those useful variables to make it a constant. And if I want to make sure that somebody else doesn't have a constant, I can call it my pi to make sure that it's not going to collide with another definition of pi. And if it's a constant, it should be uppercase. That making some sense, hopefully. So why did it have to be called my pi? Because I called it my pi. It was not, it must be called my pi. It should be capitalized, all caps, not screaming. It's saying it's a constant. But whether I called it Susan or my pi or my pi, same thing. Except this means something different. This is a pie, cherry pie. Right? So but it doesn't really matter. That was just the variable name I came up with, or the constant name I came up with. Can I unpack anything else for people? Tutorial 4. What about tutorial 4? Ooh, I forgot about that sucker. Okay. What do we remember? What the is it rand? Is there rand by its own thing? No, or and is it in the math function? I always have to look it up every single time. Let's see if I have it in here. Rand. No. Do you remember what the library is for the rand what the rand function is? It's in the tutorial's description. What library do you include? The clock, time, maybe time. Time H and standard lib. All right. Time H. All right, that was fine. Here's rand. All right, that's going to give me a random number. So my rand, because I do not come up with original names here. All right. Guess what? If I call this function 40 times, I might get the same value each and every time. So let's put that in there and printf is, and then I'll put that percentage I / n my rand. Okay. Okay, I'm going to get rid of this breakpoint here. I'm going to get rid of don't want a scanf statement, so I'm going to just comment those out. I'm going to compile it. Yes, I want to stop debugging. Oh, now that I fixed the code, great. See, I wouldn't have known if I just ignored errors. That's why we do it that way. All right, so let's run it and see what we get. Hopefully we get the same number, 41. Okay, let's try it again. 41. That does not seem particularly random. 41. 41. What the hell? The problem is they're not actually truly random. When they made the random numbers for C, what they did is they generated essentially a pseudo-random set of numbers. They generated a crazy large number of actual random numbers. But it's a lookup table. And if you start at the same point each and every time in that lookup table, you will get the same value each and every time, because it's just that you didn't change anything. You have several thousand random numbers strung together one after the other, and if I call random, I will start at the same starting point each and every time. It's not random in that case. I start at the same starting point. So what you need to do is you need to seed your random number table. So srand, and I need some kind of seed value. And so what I need to, what I really want is like the time is it time dot? It's also in the instructions for the lab. No, this can't be that. System time. There we go. What is that going to do? It's going to give me a random system time. I don't know if I need that parameter. I might need that parameter. I'm going off memory here, so it's been a while. Do you remember what the parameter is? srand. Oh, time. Maybe just time. There you go. What's this going to do? This is saying, give me the current time with my system. Now, if you can predict what the exact time the user is actually going to put in there, good luck to you, right? If this is going to give me some time value, which is something to do with my system. That's pretty random though, because I don't know what second I'm running my program from. It could be any second of any day. And therefore it's a random number. And I put that random number essentially into my random seed. It says start at that position over there. What position? Some random position based off the time of day. Okay, this will randomize the starting point. So let's build this and make sure it works. And now if I start my random number generator at any position in this random, like it is, how do I want to describe this? If I want to get 5 consecutive students in this class, if I want a random set of 5 consecutive students, I just choose some random starting point in the class and then pick up those 5 assignments or 5 students. That's what srand is doing, finding a random position where to start. And every time I call rand, I just get the next number in this random number sequence. This tells me where I start in this random number sequence. And then every time I call rand, I get the next value in the random number sequence. So seeding a random number generator. Let's just see this in action. Shouldn't be 41, hopefully. Nope, not 41. Let's try it again. That's a different number, I do believe. 19890, 19910. Right? Every single time I run this program, I should get a different value. 19936. Now, they're seem to be all somewhat in the same place, but close enough. It's a random number generator. Here's the other part about this whole thing. What does rand give you? It gives you a random integer between a set of points. There should be a rand max and a rand min. It'll be somewhere in this range. So if I want a random number between 0 and 24, what I need to do, just scale all my values. So I could do something like this. This will be a random number between 0 and 24 every single time. It is whatever my random number generator generated as a number, and see if it divides by 20 into 24. I'm either going to have some remainder. It's going to be 0 to 24, not including 24, 0 to 23, including 23, right? The remainder is actually really useful when it comes to discrete math and some of the tricks you can do. This prevents me, make sure my number is always between 0 and 23, including 23. So let's run this again and see what I get. And if it doesn't give me 16, okay, that's fine. Let's try it again. 5, okay, let's try it again. 19, right, let's try it again. 4, it's random. The original number is random, and I just say divide that by 24. What's my remainder? And that's going to be random because it's a random number to begin with. And that's the kind of thing that you're going to be doing in the lab. That gives you a random clock time to start with. And now if I have this thing right here, actually that was purely coincidental, but if I do remainder 24, I can figure out what hour in the day I'm in, can't I? So I have some ridiculously large number and I just say remainder 24, it's what hour in the day is it, right? Or this is the number of hours. So if I have this number of hours, if I do remainder 24, it says what hour of the day it is. if this was the net random number I'm generating here is the number of seconds that have on the clock, dividing it by the number of hours in a day, dividing it by the number of minutes in an hour, dividing and doing the remainder can give me the number of seconds, minutes, and hours on the clock based off of just the number of seconds that you have in total. So 400 seconds, let's say, let's keep it simple. If I have 400 seconds on the clock, how much is that? So if I have 400 seconds, how many hours is that? How many minutes is that? How many seconds is that? Well, if I say 400 and then I divide it by 60, that's how many minutes have passed. Whatever the remainder of that is how many seconds are left on the clock. If I divide that number of minutes by 60 again, I'll get how many hours are in 400. So it allows me to break the problem just little bit by little bit, break the problem into a series of remainders and divisions that tell me what the time on the clock should be. Because all I need to do is effectively all I need to do is keep around the number of seconds that have passed on this clock. And in fact, that's what your CPU is actually doing right now. Every one of your CPUs, the chipset that it uses, is keeping around the number of seconds that have passed since, I do believe, the Unix epoch time, the start of Unix when it was originally introduced. I could be wrong on this one. I think Windows might be using something slightly different. But it is keeping around some starting time as 0 seconds, and it's the number of the number of milliseconds since that starting time. And this is the number of milliseconds that have happened since then. And you just do the math to get the number of hours, what the exact hour, minute, day, year, all of that information from your operating system by just doing math. It doesn't store the year. It doesn't store the hour. It stores the number of milliseconds since since Unix originally started, or whatever the number is for Windows. Little quirky thing about operating systems. All right. Other questions? I've been talking a long time, so nice. Glad to help. I know my bit 2400 class is a little scared for stuff right now. Let me be very frank, because I'm checking with the TAs as well on this one. Let me be very frank. I would love to get feedback. This is hard for you guys. It's the first time for many of you programming. And on top of that, you don't have a TA or myself right next to you helping you when you miss a semicolon. It can be very stressful. I fully empathize and appreciate how hard this can be. So ask questions. That's what we're here for. And there's only so much we can do if you don't ask for questions. If you're doing the homework and you're plugging along nicely, then you're doing fantastic. If you hit a little roadblock, ask for help or try and figure it out on your own. We're trying to give you the tools, but it requires practice, not memorization, just practice. And if you're doing the assignments and you can do it on your own, you're golden, right? That's a pretty big, that you should, pat on the back, right? I think you're doing a great job. And if you're struggling at all, that's when you ask for help now, so we can help you out, because that's what we're trying to do. We just need to know what's wrong. Okay. If there's no additional questions, I'm going to call an end. I'm going to stop my sharing. Okay. I'm going to call an end to what we're doing here. And I'll let you go on with all your other coursework, because I'm sure you have plenty. But hopefully this was useful in some way. I might have to do Zoom, unfortunately, from now on, just because my computer crashing and dying from a thermal crash is not good. Sad face, Stuart? Okay. Okay. Oh, yes. Thanks, everyone. Have a great day, guys. Bye.
Have a good Thanksgiving.
If OBS is overheating, yes.